Hi, I'm Brian Miller-Hicks, your instructor for Geology and Earth Science, and I'm here at beautiful Torrey Pines State Reserve Beach, just south of Del Mar. So let's talk about Earth Science. Earth Science is that collection of sciences which includes geology, meteorology, oceanography, and as you can see, we have an entire Pacific Ocean out there, and astronomy. Can't show you any stars right now because obviously it's daytime. But let's look at these cliffs back behind me. This is a cliff section that exposes a couple hundred feet of old rocks. Now, rocks are the meat and the bones of geology, and this cliff shows stacks and stacks of layers of rocks. These are sedimentary rocks. That means they were laid down as loose material, sands and clays. Then through time they were buried, compacted, and cemented into rock. So if we look at the cliffs behind us, at the sort of the greenish gray material closer to the bottom, that's called a mudstone or a shale. It's made of fine particles. What does that mean in terms of the depositional environment? Well, that means they are laid down and settled into quiet water, low energy, so very fine particles could settle out through the water. Up above those fine-grained rocks are the orange, kind of orange-brown or yellow sandstone rocks, coarser grain, which means the water that transported them and the water in which they were deposited was higher energy. Maybe waves, surf, near shore environment. And actually what you're seeing here for the whole cliff is a representation of rocks that are Eocene in age, which means 33 to 57 million years old. Okay, what I'm holding here is an example of that quiet water rock, that mudstone or shale. You can see all the little white things in it. Those are shells. Here's a snail shell. Here's a clam shell. These are what is known as fossils. Animals that died millions of years ago and settled to the bottom and were preserved. At least their shells were preserved. So this rock is called the Del Mar Formation. The orange sandstone rock we see up above on the cliff is called the Torrey sandstone. So let's talk about age for a minute. Geology, the earth sciences are built on a foundation of time and process. Time is very, very important here. Processes occur within this time framework. We know now that the Earth is quite old, some 4.6 billion with a B years old. And all these things happen within Earth's history. These rocks were deposited 30 to 50 million years ago in an ocean environment. At the time they were deposited, the ocean levels were higher and the ocean shoreline was quite farther back. These are exposed now because our ocean has retreated to the west, and the coastline has also risen up, showing us all these layers of rocks that we have today. And these are great rocks to study, and they're world famous, not only for their beauty and their great exposure, but also because oil geologists look at them as examples of environments in which oil has developed and can be derived. The other aspects of earth science I mentioned are meteorology. So if we look at the sky, we have a somewhat overcast day with low-hanging clouds. We've got a steady westerly breeze, and we have fairly humid conditions. Well, the weather pounds on these cliffs. Big storms come in, rainfall happens, rain hits these cliffs and erodes or wears away the rocks that you see. So weather affects rocks, and let's look at the great mighty Pacific Ocean. And let's look at what we're standing on. What are we standing on? We're standing on a beach. How did the beach get here? Well, the beach got here because sand came from inland, carried by rivers, got to the ocean, and the ocean picked up all this sand and distributed it up and down the coastline. Waves also pull away sand. If you look at these pebbles, that's where the sand was swept away during large storms, leaving only the heavy stuff behind. Astronomy, we know that recently we've landed some explorer craft on Mars, robotic landers. All that's really exciting stuff. And we'll talk about that a little bit during our semester as well. And just one last thing before we go is I am a professional geologist. I made a career of it for many, many years. I'm an engineering geologist, which means I help engineers and architects if they want to build something, we characterize the ground that they want to put a building on. So with all that pre-knowledge of what we're going to look at and study and learn about and have fun with, I'm signing off. Thank you for watching.